SwayamPrabha. Digital India. Educated India.
Okay. So, we have been discussing about this mixed flow reactor, and of course, this is the diagram which you have given, and then we just want to know what is the concept of mixed flow. And if you do not want to use your brain like you have done in your BTech, simply saying that perfect mixing is one where everywhere inside you have same concentration and temperature. Okay. So, that will create some cobwebs, some not properly understanding things, like for example. So, the moment we say that perfect mixing, most of us feel that it is instantaneous reaction. It is not, right. Instantaneous mixing, that is correct. In instantaneous, the moment you have a concentration of Ca naught just entering, it should be instantaneously mixed to a concentration of CAF, or conversion wise XAF. CAF is safe because Ca naught is coming in, CAF is the concentration due to perfect mixing. But when I looked at that, concentration has come, that concentration in the reactor is prevailing. Please listen to this one carefully. That concentration CAF is prevailing due to elements of various residence times inside the reactor. And you know that because it is a perfect mixer, by definition of perfect mixing itself, the outlet residence time distribution and also the inside residence time distribution is exactly same. Here also you will have 0 to infinity residence time distribution. That means okay, I will take a small sample outside here, and then I will look into what are the residence times. I may see there molecules or packets entered infinite time back, that means very long time back, infinite means not really infinity. Okay. Then it also would have average residence time is 10 minutes, just for easy discussion. So, all those molecules will not be exactly at 10 minutes. So, we will have 100 minutes, even 1000 minutes, 1 or 2 molecules, right, 500, 100, 50, 10, 1, almost 1 second also. Why? All this is happening again because of perfect mixing. When you are continuously sending this Ca naught, there may be one molecule which may be very quickly coming out of the reactor and then joining this stream. So, practically that molecule is not able to react, but on the average when I look, because of the mixing, there are molecules now spent at 10 minutes, 100 minutes, 20 minutes, 1 minute and 500 minutes, all that combination, and that will give you the average concentration inside the reactor, which is also reflecting in the outside the outlet. So, that is the concentration what we see here. CAF is the concentration because of mixing of various elements of various residence times. Just extend your imagination from here to plug flow. So, the moment you have plug flow, I think this is a tubular reactor like this, and we are only talking about exit. Here also exit concentration is CAF, but what about inside concentrations? Maybe I think
varies along the length of the.
Yeah. So, if I draw this may be Ca naught, this may be CAF, and of course, here I have Fa naught, Fa and all that, right. So, we are talking about here the concentration CAF at the exit, but the moment I go inside, the CAF is different than higher than the next one. Then you move somewhere inside, that will be higher. Like that, if you come back here, then you will have Ca naught concentration. That means here what do I have? I have the concentration decreasing slowly, right, and this is Ca naught, this is CAF. Okay. Now, it is the same thing if I plot here Ca naught. Yeah, how do I plot this? This is Ca naught, okay, this is Ca, this is Ca naught. Because it is instantaneous mixing, concentration will decrease to CAF, which is this. There is no slow decrease here, this is CAF. Okay, sorry, this is only spatial. Okay, no problem. This is Ca naught, this is CaF. But now the difference, why even writing without writing equation, why a plug flow reactor should give you more conversion for a given volume, in this and here you will get less conversion for a given volume, is here the concentration is changing slowly, and then what about rate here, 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 do I have different rates? Why I have different rates? Concentrations are different. We know that at any point we have K into Ca if it is first order reaction, or correspondingly whatever reaction we have. So that means what I see at the outlet is the accumulation of all that, I don't say not accumulation, not material accumulation we are talking, the changes in reaction and the concentrations slowly, that means the number of rates I have inside the thing, and what I see here at the outlet is some kind of average of all those rates, whereas here how many rates I have? Only one, because throughout the system I have only one concentration. So that is, and that rate corresponding to CaF, outlet concentration. So is it more than or less than inlet concentration? Definitely much lesser, right? So if I mean example, if I say that Ca naught equal to 10 moles entering 10 moles per liter and outlet is 1 mole, Ca equal to 1 mole per liter. Okay, what is the conversion now? We are talking about constant density system. Conversion equal to 90%. You know the definition, Ca naught minus Ca by Ca naught. So I think for some people I think also better, right? Ca naught minus Caf by Ca naught. This will be 0.9. That is the concentration. Okay, that is the conversion which I get here in the outlet and which is same throughout, right? So corresponding to this CaF, the rate if I calculate minus Ra equal to K into CaF, only one rate, which is very low, that means that is almost the exit rate, right? So now in our design expressions we will have always this rate in the denominator by Ra, okay, by something by Ra it will come. Now here I have only one rate and the rate is very less, okay. I mean very less means it is not, I mean it is corresponding to exactly this rate only, okay. Here also if I have 90% conversion, here also I will have 1 mole per liter only, right. I mean for comparison sake, please remember that. So here also I have 1 mole coming out, okay. Yeah, here also we have 1 mole per liter and here also I have 1 mole per liter only, but before coming here as 1 mole per liter it would have gone through so many rates. So rate means already some conversion would have occurred, right? Whereas here there is only one rate and one conversion and one concentration. So this rate is, because the average of that is only one rate, whereas here there are so many rates and then all of them giving me more conversion when compared to this, because I have only one rate here and I have here, theoretically how many rates you can put inside? Imagine infinite, because that is the reason why at every cross section again we are thinking that we have infinite mixing. That means each cross section now depends on one, is equivalent to one tank. So infinite number of tanks you can put there. So that is why you have here more conversion for given volume and here you have less conversion for given volume, because the rate is only one, that Ra is small now, but only one rate, and that is the reason why you have larger volume for a given conversion, or for given volume higher conversion, right. So that is what you have to remember. I think this should go out now. I think after this course definitely at least the basic definitions must be very clear in the mind, right. Why plug flow is efficient, what is the definition of plug flow, what is definition of mixing. I could have completed this long time back if I don't discuss much about simply saying that assume complete mixing, but still you will have many doubts in your mind that what is this perfect mixing and instantaneous reaction you feel. There is no instantaneous reaction, there is still an average rate, right, average rate due to various residence times inside the reactor. Whereas here I have all the residence times of all the molecules are exactly same here. We are talking about outlet, here also outlet only, but outlet and inlet exactly same here, right. Whatever is happening also reflect in this one. If you have doubts, you have to raise and ask me, right. Okay. So that is how it happens that PFR is definitely having more conversion for a given volume. If someone is asking you in the interviews or in some examinations this question, probably you have to definitely imagine that this residence time distribution that is coming into picture. That is why by definition of plug flow we say that each and every molecule should spend exactly same time, and there we can prove that that is not so in a mixed system where the residence times are varying from 0 to infinity, right. That means the molecules are packets which are spending 1 minute less conversion, 2 minutes slightly more conversion, 1000 minutes 100% conversion, but there is no use of that being inside because it is like it is already converted, there is nothing will happen, but still that is occupying some volume, right. So that is why to compensate that volume, if you want to get the same conversion as plug flow, what do you do here? You increase the total volume. That is why for a given conversion the volume of plug flow will be smaller and the volume of the mixed flow will be larger, because you want to compensate the rate lost due to residence times. So see here every particle is spending exactly same, means the concentration is or conversion is same in each and every pocket, right. So even if I take the average of that, definitely I will have same conversion, whereas here I have 100 pockets, I mean here also 100 pockets but equal concentration, here also 100 pockets but starting from Ca0 to CAF, that I am again averaging, right. So that will definitely give me less conversion, but what I am trying to do is I am now trying to provide more volume so that some more time all these pockets will on the average, okay, all these pockets again are going to spend time. So that is why that will compensate this conversion, higher conversion here by increasing the volume. Anyway, even if you derive the equations and then able to calculate, you will definitely see there are many graphs. I think 11th PL book has given that for given conversion what is the volume for first order reaction, second order reactions, third order reaction. You will just go take 90% line and then read this side, then you will know what is the ratio of volume of CSTR, single CSTR, and volume of PFR, that ratios are given, right. So directly some people may give always in chemical engineering we use a lot of dimensionless numbers. So volume of mixed flow by volume of plug flow also is a kind of dimensionless number, okay, and conversion is anyway dimensionless number, but it will be depending on again what is the order of reaction. So you have one line for one order of reaction, then you just read and then okay, for first order so much difference, second order so much difference, okay. So that is why one can also easily prove it. So if you have still further any doubts about mixed flow and plug flow, now I think we are going to stop that now, right. So please tell me, please ask me, please do not keep those cobwebs again, okay. How do you operate CSTR? Okay, see we are talking about only steady state system now, but how do you come to that level where you have 0 to infinite residence time under steady state conditions? So that means you can slowly fill up the entire empty, take empty and then slowly fill up, so level rises and then after that it comes out, okay. So then what is the concentration when it is about to come out, because our steady state starts only at time t equal to 0 outside. Yeah, but I think we have to be specific here. Slow means how slow you are talking.
At least 6 hours it is taking.
Yeah, even 20 hours also we can run here. 20 hours, but we are talking about average residence time, right? Yeah, see very slow reaction means it may take more time for the reaction to happen and maybe much more time the moment you want to go to 99% conversion.
Also I need some reflux in the reactor.
What do you need reflux?
In some reactions if reflux is required.
Yeah, tell me why. See, these are all vague things in our mind. That's what exactly I am asking, that cobwebs. So why should I use a reflex in this reactor?
That is boiling of the reactor material.
What should I do?
Perfect mixing anyway.
Under what conditions? Yeah, there is perfect mixing in this system when you are talking. Why should I boil and why should I reflex?
There are some reactions that doesn't take place in normal temperature.
Like what? I mean, we should also be clear there, right? Like what?
It has to be taken up to the boiling point of the mixture.
Okay.
Then body flux will come back.
Yeah.
We have to put a.
What for you are doing that?
Suppose some.
See, I mean, his question is that I have a liquid where the boiling point is only 60, example. But the reaction is taking place maybe around 100 degrees centigrade. Okay, it will not happen normally, but you know,
Material in the.
you can conduct in gas phase. But the problem comes when you have two reactants where one boiling point is higher, another boiling point is lower, and if the reaction is somewhere above or in between, then the low boiling point one will be boiling. You have to keep the number of moles same. That is why what you do is either you put a condenser so that it evaporates, immediately gets cooled and then falls there. But that is not the reaction problem. Okay.
Then how to take that material outside?
Which material? It is only just distilling there and then falling there. So then no question of taking out. Okay, that is the easiest one. Otherwise, you can also put a outside condenser and then again feed back. Under steady state conditions, the number of moles will be kept same. Okay. So that is only, you are only trying to see that the concentrations are not changing due to evaporation. That's all. That is only the physical thing. It is not the actual reaction. Because if I allow that to go out, then you will have one reactant. Yeah, you lose one reactant. Right. So that is why just close it perfectly. Otherwise, I told you in our villages when they are cooking rice, I told you, they put water just above and then cook, because that is also same thing. Water should not get evaporated.
In that case, how to use CSTR?
CSTR will not change. No, I think you have perfect mixing there, and I close this. Okay, here I have, and then you have the outlet somewhere here, right? So put a condenser and again send it back. That is only the engineering problem, as a mechanical engineering problem, where how do you put that to a hole where the vapor is escaping, where it has to condense and it has to come down. That is all. Okay. And for that condenser again you should have some coolant entering, coolant coming out and all that. That is just only engineering problem, it is not really CRE problem. Their CRE problem is that you should maintain number of moles, not uniformly, the way it has to be in normal reactor. So that is all. But other than that there is nothing special in that kind of thing. Not only that, there I think this question is good. Now because he is asking only reflux, but I can extend this question to heat transfer. If the reaction is highly exothermic, right, simply putting a external jacket may not give me that kind of area where I can control the temperature. Highly exothermic, I want to control around maybe 75 degrees, but with providing only that jacket and also whatever is available coolant, right, still I may be getting around 90. What do I do? So people take out a stream there, put an external heat exchanger, again send it back. That is one way. Other way is directly put the coils inside. There are many ways. Or again inside also you have all the time, instead of wall you have only coils. These are all again mechanical engineering problems. How do you remove the heat? If the area is not sufficient. Even for batch it is same, it is not only for CSTR. Even in batch reactor, if only jacket is not providing sufficient area for removal, then you have to go to various means of removing, putting internal coils, because sometimes internal coils you cannot put because they may be highly corrosive liquids. Okay. So then you have to take out and then
Also decrease the volume of the reactor, effective volume.
Effective volume will be good. Effective volume will also decrease, and mixing may not be proper, because inside coils if you put, near the coils again mixing, these are all general engineering problems. That is what exactly the difference between science and engineering. A scientist will not bother about all these things, you somehow remove the heat. Okay. So that is what I have been telling you, the difference between science, engineering and technology. Technology is the one where it is ultimate, telling you that use this temperature, use this flow rates, use this volume, you will get this much product. And this technology does not need any brain at all if you want to just copy one technology, that is all. That is why I do not know, you may not, anyone has worked in pharmaceuticals? Oh, you worked now. Which pharmaceutical is that?
Orchid chemicals and
Oh, here.
No sir, at Aurangabad.
Oh, Aurangabad also they have unit, I know. Yeah, okay, good. So earlier when we were doing also our BTech and MTech, have you heard of a company IDPL? Hyderabad. They had various units, but Hyderabad was mainly pharmaceutical unit. They have surgical unit. IDPL means Indian Drugs and Pharmaceuticals Limited. Okay. Totally that was destroyed by the people who are working there inside. You know, the employees. Employees. What they did was they just duplicated the technology. There was some sulfur drugs, this drug. I also took training at that time. In RIC Warangal was one place where we had what is called chemical plant engineering, even in BTech. So one semester we have to go for industrial training. One semester, it is not in between the semesters where you have 3 weeks, 4 weeks like that. So 1 week, one semester we were there in Hyderabad. Some people went to FACT, Kerala, FACT, and some people went to Bombay, NOSIL. And because at that time, of course, our strength was only 30. Now also maybe, I don't know, 30, 45 they increased. Okay, in RIC Warangal I am telling, now NIT Warangal. So when we went there, at that time it was running okay. But after 10 years later when we saw, then in the news and all that, entire company was totally destroyed. What happened was the people who are working there, they simply copied the technology because we know only temperature, pressure, what is the size of the vessel, simply duplicated outside, very near to IDPL only. You know that Balanagar area, I don't know what, you are familiar with the thing? Yeah, there were many pharmaceutical companies that have come there. All of them, normally we have a partner called wife, so wife's name, that company, because this fellow cannot start on his name. He is working still there, he is getting salary here, but he is producing the same thing in some other unit, and then he was trying to send it to other, not export, but other companies where most of the pharmaceutical companies, if they are producing headache tablet, they collect material here and there and then only mix and then tablet and then give it to you, putting Novalgin name or Disprin name. Okay. Now I don't know, now Chinese are dumping, I think, a lot of those things here, right. So, but unfortunately what has happened, or fortunately we don't know, what has happened there was that if there is some problem there, they were not able to solve, because they know only that temperature, that pressure, that volume of the vessel, and that is all, that kind of stirring. And many units have been closed maybe after 5, 6, 7, 8 years, because the product was not coming the way they expected. Most of the time the color is changing, because you do not know how to control that. There are no fundamentals, that is what technology is straight. But even then few companies have survived, because now they use it, they have started using their brain. That means they went to technology to engineering, how to solve that color removal for example, and then from there to science if it is required, right. That is one way. So technology, engineering and science. In the beginning itself you understand all the science in the lab with the help of chemists, right, and then try to find out under what conditions you will get very purest form of product, when you do not get the colors, all that you understand, and then start. And engineering principles are heat transfer and heat removal for example, or heat addition or stirring, or collecting the filtration, tableting, all these are engineering applications, engineering principles. So then finally Novalgin tablet will have this condition, this condition, this condition, this condition if you want to produce Novalgin. That is what is technology. Because again I am just giving you, many people lifelong we may not remember what is the difference between, or we may not know what is the difference between science, engineering and technology. This Saturday I was there in Guntur, one college, RVR JC college or so, and because my friend is vice chancellor now in Vigyan, we both did PhD here in IIT Madras. So one VG Rao, Professor VG Rao. So he was also there in Vignan University. He also just asked me, just why don't you come there, because I had morning off, afternoon there was a lecture. Lecture is not for students but for faculty only, their faculty, not chemical engineering, all faculty about research, that is why I went there. What is the reason? Because there are many, they have 240 faculty members, out of that maybe I think around 30 or 35 or maybe around 30 have the PhDs. Okay. You may think that so what, I think there are many people with PhDs who do not know anything still. Okay. But I think in an academic institution that gradient must be as much as possible. Gradient means PhD to BTech teaching. Now if you go to many private engineering colleges, BTech teaching to BTech. Okay. He would have just finished now final year and would have got the result, and immediately he is asked to teach again BTech people, maybe third year, second year or whatever. So where is the gradient, that delta C concentration gradient? Because I think this fellow is in equilibrium, that fellow also maybe how much time, maybe 1 year before or 6 months before. So that accumulation of knowledge is not that easy to do. So that is why I just went and told them that unless at least for your self confidence, even if you do not teach well, that confidence you will have at least, okay, I can teach if you do PhD. And when you are doing PhD, a good PhD make you think, that is all. So wonderful quotations are there. Aurobindo told that no one can teach anyone, really, no one can be taught. When you are listening to me, that means your mind is already thinking about that, that is why you are listening. So but only thing is, as a teacher I can only make you think. That is what all my classes last 15-20 years, before that I do not remember what I have done. Okay, first 5 years or so, right. So that is why so many questions I raise even if you do not raise, because those questions are supposed to make you think, that is all. Why I was telling was that I asked the same question in Vignan college. I asked the same question, what is the difference between science, engineering and technology, and I also asked them, I do not know whether I told you this particular thing, okay, in the last class, I mean in the beginning. I asked them, I think there were chemical engineering students only I met in Vignan, and I told them that you have written your examination, that MSET entrance examination in Andhra, okay, they call MSET, still they call MSET or yeah. So that examination and your subjects were maths, physics, chemistry, correct, no, only maths, physics, chemistry. Then you join here in RVR JC college in chemical engineering, and do you know what is the degree you are getting? That is what I asked them. Some people kept quiet, they do not even know, poor fellows, nice guys, they do not want to know what is the degree also. So some people said that, sir, we get technology. Yeah, that is what precisely I wanted to ask you. You started with the basic sciences courses and then you passed them. Then suddenly you came to RVR JC, and then depending on your rank and all that, then you are given chemical engineering. Okay, it is not chemical technology what they got. And at the end of 4 years you are going to get chemical technology. Have you any time thought what is the connection between these three? I tell the same thing everywhere. Okay, did I ask this question? Okay, I also told you. Yeah. So not even one could not. And I saw there were some 6-7 faculty, and the faculty members, at least I observed some 3, that their face also has shrunk a little bit. That means they also do not know. That is not their fault. I am not finding any blame. Okay, because I was interested in that, so I first questioned myself. I also do not know when I first joined here what is the difference between science, engineering and technology. Later I have to see many things, because no book you find this, I tell you. And some journal papers are about technology. You have to go to humanities journals and all that, finding out what is the definition of technology. So when I am doing it only, finally I thought that this is the logical explanation for, and now I think many people say that this is the same thing what we are discussing. So that is why the technology is totally different, but always you can start from technology to science or science to, that is only left to you. But there are some things where you cannot start with trial and error. For example, aeroplane design, okay, or rocket design, these are all highly sophisticated. Okay, they have to solve all the fluid mechanics equations. There are only 2-3 forces, right? Buoyancy, lift and drag. That is all. You can make, I think, even 100 tons object to fly using only 3 forces, but you should have the feel for that 3 forces. Okay, then only you can solve that problem, otherwise you can't. And you do not have to worry drag, lift and what is the other one? Buoyancy when you are designing a bullock cart. Correct, no? In villages, who is using computer to design bullock carts? No one, no, very happily they will do it. I think this is by experience, family wise it will come. One family in the village will be experts only in making bullock carts, so they know what is the size of the wheel. But if you go to science again, there is tremendous science, and the science through technology those people have perfected. And by wrongly designing the lengthwise and where you keep those, I am talking about bullock cart, where you keep those big wheels, why should there be first of all so big? There is beautiful theory in that. And where in between you put, is it in between or somewhere slightly behind or slightly front? If you change wrongly, the bull will die, then you have to pull it. Yeah, because its neck will be strained. That design also is there in that, but by experience they got it. Okay, so that is what is technology. For example, brick, I told you, another example, brick technology. Try to make scientific bricks, then you have to go to materials, what is that, material science course what you have taken, and you have to find out strength of this each grain and strength of multi grains. How do you put them? What should be the amount of mud? What should be the amount of the solids? What is the particle size? How the orientation? What is the temperature to center? All those things, that is science. How many people are using that? Still many houses are safe, no? I think many houses are safe. So that is why I think all these things are also important, but you have to think about this, you have to discuss in your mind. Finally there also I told all faculty, most important thing is for all of us is that this brain. Okay, unless you have that good brain, you can never deliver either in teaching or even in research. And 3 hours I have taken continuously. Okay, they have not slept, I can see that. Okay, they have not slept. I think in between jokes and all that were there, so I think I thought they have enjoyed. That too when? Saturday evening 2 to 5. Very difficult to, I told them it is very difficult to keep you here, but still try. That is all. I think except some 4 or 5 where they have to go, I think there were almost around 150 people. I think only 4 or 5 people went after last half an hour, that is all. Maybe they have some work there. Okay, anyway, so this is the one. That is why I was trying to encourage you to take to think and then ask me questions. If you do not get that any doubt now, when you are preparing for the exam you will get definitely doubts, so at that time you can ask me. Okay, yeah, good. So this is the one. Now once we understand this, here we have developed an equation, right? So that equation was V by F naught equal to, these things you have to remember, whoever it is, dxa by minus Ra. Now let us also derive an equation for this, which is very simple. Okay, so for this mixed flow reactor also, when you are writing an equation, it is isothermal. So we have to write only mass balance equation, and mass balance equation MB for A, this is MF for design equation. Yeah, MB for A will be, universal equation tells me it is input of A equal to output plus reaction plus accumulation. Okay, and as I told you that we are steady state people, so that will be 0, and the this mass balance you can write, mass means mass only, no kg, right? I have to write kg entered, kg leaving and all that, right? But we can also convert that into moles. But why do you do that in chemical engineering, particularly in reaction engineering? See, the moment you go for distillation column, do you use moles? How many entering, moles coming? What do you use there? Huh? Bala? No, you are not, you are Bala, no? Ah, okay. Huh? Input I am talking about. Input to distillation column. Mass only. Normally standard question is 100 kg per hour. Right? Okay. Yeah. So like that only we don't use. And for example, heat transfer. These are simple things where you would have not thought. I say that's what only I am trying to give those connections. Right? And I think I also found in some interviews when I ask, okay, why are you using moles in reaction engineering, and in heat transfer and mass transfer when you are using only actual mass kg in terms of kgs, I do not get answers easily. And the same problem even in mechanical engineering, when you go, even for chemical reaction they use mass, they also use combustion, no? For combustion reactions they simply write 12 kgs of carbon reacting with that. Easy to relate, easiest one is 1 mole 1 mole 1 mole depending on the stoichiometry, otherwise 1 mole needs 2 moles to give 5 moles. Otherwise you just now see that maybe 100 grams here, okay, 100 kgs here, another 500 kgs here, giving me 600 kgs. Mass cannot be produced suddenly anyway. So that balance. So that is why instead of that, this is what exactly what you have also done in your batch reactor design problem. If you convert everything into moles, that is easy. What you calculated, that 769 divided by number of batches, no, that 10 tons divided by number of batches is only mass. But if you convert that into moles, then so many moles have been produced. Acetic acid, no? Ethyl acetate, sorry, ethyl acetate. To produce that, how many moles of acetic acid is required? I think acetic acid is the key component there. So many moles, but you can calculate maybe 6 moles, but this 6 moles equivalent to only 30%, because your conversion is only 30%. So that is why you have to now compensate that, and you have to take that divided by 0.3 will give you more number of holes that should be in the reactor. What you have assumed is 100% conversion with the first time when you made that mistake. So that is why very simple balance only. That is the reason why all the time we will go for moles. That is why here also we will have moles per second, because it is a flow reactor. So and I know here our units, Fa0 is moles, volume is volumetric flow rate, meter cubed per second. Ca0, either you can use kg moles or gram moles per per liter, and Xa0 equal to 0, anyway that does not have any units. So here I will simply write Fa 0, number of moles that are entering per unit time, and output is Fa F, very simple here. Then reaction is minus Ra into V is the total volume. Earlier we have taken only only differential element, that is all what the volume was. This is dV. Why? Again I am telling you. So this is the distributed parametric system. That means there is a distribution of concentration along the length. It is not one concentration, it is not lumped. Lumped means everything together, right? So that is the reason why whenever you have changes within the system, either temperature or concentration, because we are talking about either energy balance or mass balance or momentum balance, these three, right? So there you have to assume a small element, and finally when you write input output and then expand that with boundary conditions, you will get a differential equation. Whereas if in lumped parameters, that means everything together, there is no change at all here, you do not get a differential equation, you will simply get a algebraic equation. So that is why here minus Ra, change is only in this V, total V, there is no change. If I take a small element here, what do you write? I can't write anything, because concentration is same. Concentration is same throughout that element, Ra is also same throughout that element. Not only that element, entire system Ra is same. So I cannot write anything, changes. So that is the reason why you take the whole volume Rv, anyway that is equal to 0, right? So this, if I write this will be Fa0 minus Faf equal to minus Ra into V. So in our normal terms, in conversions, if you are able to express this, what is the conversion equation we have given for flow system? Fa0 minus Fa by Fa0. Faf here is, otherwise I have to put Xaf here. Okay, good. Anyway, we will put that one here. So now, this Fa0 and Faf, if I convert this into Faf, this is general definition of X, right? So then what do I get here? This is equation 1, equation 2, equation 3, equation 4. Then replacing equation 4 in 3, please write there, replacing equation 4 in 3, that will be Fa0 Xaf, because we are talking about this is general expression. okay, or if you are getting confused, no, but I think no, not required, I say. That should be general expression and you should be able to extend that, okay. Yeah, so XAF equal to minus RA into V, right. So in this format, when I want to compare, this will be V by F A naught equal to XAF by minus RA. So this is the equation what you get. This equation is 5, right. What is the difference between this equation and this equation? What does that tell you physically?
You are different.
Mix up all the delta V.
Huh?
We are taking the average.
There will be a rectangular area in the graph. Where you got 1 by minus RA and X, and there will be an integral area for graph.
Yeah, but within that integral you have that RA. So what does that mean?
Different rates. Different rates.
There are so many different rates where you are having some kind of average of rates all there. Huh? Yeah, whereas here there is no average.
You have
There is average but only one.
one rate.
Okay. So that is why you will get here simple algebraic equation. There it is an integral expression because all these rates at various points I have to also average, and that comes through mathematics under that integral. So that is the reason why if I plot this integral, I mean this equation, I will get here 1 by minus RA versus XA, you will get this, and this is the area under the curve. This is equal to V by F A naught. Same thing I also draw here. This is also 1 by minus RA versus XA. I get exactly, rate will not, 1 by R will not change, it is same thing, right. For a given conversion, same XAF, it is XAF. Here also XAF. What volume I have to take now? Not area under the curve, because there is no integral there. So I have to have this integral, that rectangle area. Okay. So then this entire thing now will be V by F A naught. And you see, this is the area in terms of volume, what you have to spend or what you have to provide more to compensate all that residence time distribution. That is why, again I can tell you that. Yeah, because this volume, this is the extra volume where why this is happening? This is happening because I have more and more, more and more packets spending less and less time inside the reactor. So to compensate that, I should have this much area above. And why should I take rectangle? This is another question which I ask, many students may not answer. Why should I take, sorry? Tell me, Anupriya.
And the maximum.
No idea. Yeah. Who else can say? Purvali? Why should I take here rectangle? There of course area under the curve is that integral what we are talking. So many people may not know. Devayan, you have any idea?
The right hand side tells us XA by minus RA. So if I am plotting 1 by minus RA into XA, so X into Y, that will give you the rectangle.
Yeah, I think most of us may not get that because it is 1 by minus RA. Just assume 1 by minus RA equal to Y. Okay, simply 1 by minus RA equal to Y. Now this is Y into XAF. So Y is X into Y, area of a rectangle. That's all. I think, but many people don't know that. Many people, in my experience, I talked to many students, they are not able to answer that. Why that is coming? Because simply instead of writing Y, we write 1 by minus RA. So that is what we are doing wonderful things in mathematics, because mathematics course is mathematics, totally segregated. We don't know how to bring that information to our engineering. That is why we started talking mathematics of chemical engineering, so that once more can we combine. I think dy by dx you know how to solve dy by dx as a function of some x and y, but the moment I write dca by dt, no idea. dca by dt also is a first order differential equation, is a function of some concentration. So then we don't know how to do that. So that is why I think those mathematics are taught only for you to make comfortable in these subjects wherever these mathematics come. So that is why this is simply I think followed, no, all of you. You see, whenever I have a graph like this is y, this is x, and this is y, this is x. So what is the area of this x and y? Okay. So that is what we are doing. Instead of writing 1 by y, we have written 1 by minus r a, which is a parameter like y into x will give me the total area, which is coming from this equation. I have not done something else, it is coming from this equation. Whereas here this will tell me from calculus that this is the area which I have taken a small strip, calculate what is the area. What is the area there? It is delta x multiplied by y. What is y there again? 1 by minus r a. So y dx, and then y, not y dx, y. This is what is this, where we are averaging all this in this equation. So you will get the average rate definitely more than the average rate of this. Okay, you understood, no? This average rate is more than the average rate of this. So that is why this is more. More means you are dividing dxa by minus ra, more, larger number. So volume will be less for a given conversion. That always you have to tell. Okay. So because it is minus ra is small there, that is why when you are dividing with a smaller number, this volume will be larger. Okay. Good. So now when you compare this equation and this equation, where is tau coming there? Why do we worry about tau there? In fact, tau is not required. Correct, no? By writing the natural material balance means moles, you automatically get only V. Why should I calculate tau, and tau equal to again volumetric flow rate, another subroutine in the mind. So many things I have to remember. So simply that is why straight away go for V by Fa naught. But why that tau has come? Can you just think why that tau should have come? You are cross now? Yeah. Can you just think why that tau would have come?
Fa0, which is molar flow rate.
Yeah.
So
what?
it's
V by V naught. And I know moles also you can calculate, or concentrations also you can calculate, because these two are known. Volumetric flow rate also you can calculate. But why? Why this another headache, or in Tamil that song, why this Kolaveri? What is that, Kolaveri only? Yeah? Huh? Correctly pronounced? I am here 35 years, but I don't know how to speak Tamil. I understand. Yeah. So why that Kolaveri? It is not required, no? Can you think why that? Huh?
That should be
Savita? What?
time of operation is not so that we can give reference time.
It is steady state, no? See, this is a steady state reactor. Why do you need time? Do you need time? For steady state means once you start it goes to how many years if there is no problem. Correct, no? Time will not come here. If you are batch reactor, then I have to tell time.
It has to hold
Volume directly I am getting.
reactors for last time residence time so that the reaction gets
But why do I want to know that?
So there should
Because I don't need, no, because for producing that much conversion I need that much volume. It is steady state reactor, and volume let us say 2 meter cubed I got. Why do I want to know again time? I am not saying whatever you are telling right or wrong. I am just only making you think. I cannot teach you anything, so I am just making you think. Huh? Flow rate, MBA, first I think management market survey. Flow rate, that is the one thing which you know before even starting the calculations. Correct, no? You should know what is the capacity of the plant. What do you do? Either you do market survey, or you will hire say MBA guy, and then you go and get all the data. How many tons?
how much time we are going to get this much conversion.
It is a steady state one. Why do you want to know how much time? Continuously it is coming. Once it is once it attained that conversion, okay, under steady state conditions, where is the time coming there? Answer is very simple, because unfortunately we started derivation batch reactor, because batch reactor has T by C naught equal to now whatever we studied in LKG only, that is strongly printed here, correct? No, you don't forget alpha betas, no, when LKG. So that, but this is LKG for us, batch reactor was the first. So there it is in terms of time. Now we thought, always we should have other reactors also in terms of time, which is not required. Okay. So this time is the batch time, batch reaction time. So because I have this T by C naught, I would also like to write this equation as tau by C naught, so that I don't have to remember. That's all, only for that reason. Otherwise, if you want to really calculate volume of the reactor, you don't need that. That expression is sufficient. That's why just remember that. I mean, it's not a great thing what I am trying to tell here, but some things which are not useful, not required for us. Right? You understood, no? Only for similarity, because that is tau. Right? This is T by C naught, which we started our BTech, the first reactor. So that is why now our mind goes, okay, now let me also write in that same term, so that same format, so that I will remember what is the uniform format. So now this we can convert as tau by C naught and write for mixed flow. That also you can convert as tau by C naught and write, because V by F naught equal to tau by C naught. No, you know how that comes, where tau is defined as volume by volumetric flow rate.